Hey there guys, Paul here from theengineeringmindset.com. In this video we're going to be doing some fan calculations, and we're going to see how to calculate the fan pulley diameter, the motor pulley diameter, the fan revolutions per minute, the motor revolutions per minute, and also what the adjusted airflow rate would be if we were to change these. Now with the fan, if it's already installed, then you should get a sheet that looks something like this, which tells you this is just the design data. So everything you need to know about the fan should be on here. Unfortunately, all too often you're going to come across sheets like this and they have not been completed. There'll be data missing. For instance, here it doesn't mention anything about the fans and filters, which are going to be in this system. But if there are blanks in there, then we can look today at how to calculate these and fill the blanks in. And if you're designing the ventilation system, then we're going to look at the calculations for how to actually calculate and enter these values. Now we're going to be using a few technical terms today, such as fan, motor, pulleys, RPM, etc. So just to bring you up to speed with that, excuse the pun, we've got the motor here, then we've got the fan over here. Now these two which are connecting, we've got the belt pulley here. So this is the pulley wheel, and this is another pulley wheel. So this is the fan pulley wheel, this is the motor pulley wheel. When the motor spins, obviously that's going to transfer rotation over through the belt and into the pulley of the fan, which will rotate that. And as that fan begins to spin, that's what provides and pushes the air off into the building. So the rate that the motor spins is known as the RPM, the revolutions per minute, and also the rate that this pulley spins is also known as the RPM, or revolutions per minute. So we'll have a look at what size they need to be and how fast they need to spin in order to achieve the right flow rate, and if you were to change them, what the airflow rate change would be, the adjusted value. So the first one we're going to look at is calculating the fan pulley diameter. Now you can see I've split the screen into two here, so we're going to have the metric and imperial calculations on here. And we've got a formula up here. I've tried to color code everything throughout the video. I find it just makes it a lot easier to follow the numbers. But the formula we need to do this is the fan pulley diameter is equal to the motor pulley diameter multiplied by the division of the motor RPM divided by the fan RPM. And we've got some data in the calculations here. So we can get these figures from the manufacturer. If you haven't already purchased the equipment, then you can look it up online and see what the RPM is going to be for these fans and motors. For the fan, that's going to be the RPM you need to provide X amount of ventilation or airflow rate, and the motor, this is the RPM that it's going to rotate at. So for the first one, we've got a 95mm diameter pulley on the motor pulley diameter. So on here there's 95mm across, or 3.74 inches, and we know that the motor is going to be rotating at 2,861 RPM, same for the imperial, and then the fan, in order to achieve the airflow rate that we need, it's going to be rotating at 3,020 RPM, same for the imperial. So if we do the division first, then you'll see we get less than 1, so it's 0.94735%, and it's a percent because we're doing a division of the same units here, so these both cancel out and it becomes a ratio, so it's a percent. And we've got 95mm multiplied by that percent equals 90mm, so or 3.54 inches. So the fan pulley diameter, this spinner here, that needs to be having a diameter of 90mm in order to achieve the design that we need. Now another way to calculate this, if we were to have slowed the motor down, or we've changed the flow rate that we need servicing the floor, say half the floor is cleared out and we want to make some energy savings or change the design data, then we can use this formula here. So the new fan pulley diameter is equal to the old fan diameter pulley diameter multiplied by the old airflow rate divided by the new airflow rate. So for this I've just put in a 10% reduction from the original, from the design data, and if we punch those numbers in, and we can use that for the imperial side as well, Doing the division obviously cancels that out and makes that a percentage or a ratio. So it's 1.11%. Multiply that by the original fan pulley diameter, and that gives us and lets us know that the new diameter needs to be 100 millimeters or 3.93 inches. So the next thing we can calculate is the motor pulley diameter. Now there could be various reasons why this has changed. Say there's a new motor being replaced, etc., etc., a new fan has come in. So you want to know what diameter that pulley needs to be to achieve the correct airflow rate. And for that we'll use this formula here. So the motor pulley diameter is equal to the fan pulley diameter multiplied by the fan revolutions per minute divided by the motor revolutions per minute. Again, you can get this information from the manufacturer or from the design if it's already installed. So if we just drop the numbers in, so we'll, on the fan we're going to have a 90 millimeter diameter pulley or 3.54 inches, and we'll do the division between the two RPMs, cancelling out the RPMs, leaving us with 1.056%. Multiply that by the fan pulley diameter, and that gives us what the motor pulley diameter needs to be, which is 95 millimeters or 3.74 inches. Another way to do this, if we know there has been a change in the flow rate and we need to know what the change in diameter for the pulley will be on the motor, then we can use this formula here, which is the new pulley diameter is equal to the old motor pulley diameter multiplied by the new airflow rate divided by the old airflow rate. Now we know what the old airflow rate is and the diameter of the pulley. The new airflow rate, you can calculate that, and we will shortly in the video, or you can take it from the new manufacturer, etc. But if we drop these numbers in, then obviously these will cancel out on both sides, so that will give us a percent again, and we can see that the original pulley diameter multiplied by that percent is equal now to 85 millimeters or 3.73 inches, and that's the new motor pulley diameter. So then we can look at what the fan RPM needs to be in order to achieve our design criteria. And for that we'll use this formula here, which is the fan RPM is equal to the motor RPM multiplied, and we already know these figures here. We should have calculated them or taken them from the manufacturer of any new equipment or from the design data. And so if we drop the numbers in, then obviously we'll get down to a ratio again if we do the division of the pulley diameters, and then we can multiply these together, and that will bring us to 3020 RPM on both metric and imperial. Obviously it's the same units there, and that is the speed that the fan needs to rotate at to achieve the design flow rate. Now we can also calculate the motor RPM, and we do that using this formula here. So the motor revolutions per minute equals the fan pulley diameter multiplied by the fan revolutions per minute divided by the motor pulley diameter. And so we can drop those numbers there in, and this will then come out at 2861 RPM on both sides, imperial and metric. Again, you can just calculate these or look them up from the manufacturers. Now if you have made any changes to the fans or the motors, etc., then we want to know what the adjusted air flow rate will be, and will it satisfy the design criteria, or are we making a reduction in order to reduce the airflow rate to make some energy savings. And if that's the case, then we can use this formula here. So the new airflow rate is equal to the old airflow rate multiplied by the division of the fan RPM, the new, divided by the fan RPM of the old. So we can then stick these figures here in. So we know what the old flow rate was and what the adjusted RPM is going to be in the original RPM. So we'll stick these all in, and this will bring us down, obviously, down to another ratio, and we can multiply that out, and that'll bring us to 1.638 meters cubed per second. There should be a cube there, or 3,470 cubic feet per minute. Okay, that is it for this video. Thank you very much for watching. I hope you've enjoyed and it's helped you. If you have any questions, please leave them in the comments section below. Don't forget to like, subscribe and share, and also check out our website, theengineeringmindset.com. Once again, thank you very much for watching.